Recording now.
Hey, Alexis and Dalton.
She's the only one. That was from Amory because she's sweet. And that's to Leah. So we're looking at rational exponents today, and I got started and then I remembered the video. But we were talking about when you have an exponent that is in fraction form. That's called a rational exponent. The bottom number tells us what our index is going to be, and the top number tells us what power we're going to raise it to. What's interesting with the power is you can either raise the base to that power and then take the nth root, or you can take the nth root and raise the result to that power. So we're looking at example 1. What is the simplified form? 625 to the 1/4. That tells us that 625 goes under the radical. What power are we raising it to? The first power. And what is the root? What is the index? 4. So this is really just the 4th root of 625 because 625 to the first power is 625. When you see one, when you see one with a 1 on top, then you know that that is just going to be like the 4th root. If it was 1/2, it'd be the square root. If it was 1/3, it'd be the cube root. You're not really going to raise it to the first power. Anything raised to the first power is itself. So then we would simplify this. What is the 4th root of 625? If you don't know it off the top of your head, you could break it down and you would circle groups of how many? 4, because it's a 4th root. But Terry was sweet and told us that it's 5. Okay, 5 raised to the 4th power is 625. That's it. You can, but I'm going to have you show me. Okay, looking at this one. We can look at this one of 2 ways. When you're multiplying the same base with different exponents, what do you do to the exponents? You add them. What's 1/2 plus 1/2? So this answer is 12. Now, that's just using our exponent rules. If we use what we've just learned, what does the 1/2 mean? What root is that? The square root. So really what we're really saying is the square root of 12 times the square root of 12, because you have 12 to the 1/2 times 12 to the 1/2. So the square root of 12 times the square root of 12. And what's the square root of 12 times the square root of 12? 12. You get the same answer either way. Yes. So, we have 2 ways of working this problem. One is our old rules that we already know about multiplying same base, different exponents. If you have the same base, like 12, and you're multiplying, you can just add the exponents. 1/2 plus 1/2 is 1. So we get 12 to the 1, which is 12. But the new stuff that we've learned is that 1/2, this bottom number tells us that our index for the radical is 2. Anytime you see a fraction exponent, you know you're going to have a radical. And the bottom number tells you what the index is going to be. Well, an index of 2 means the square root. So you have the square root of 12 times the square root of 12. Okay? And so that's going to be the square root times square root. It's whatever you have under it, 12. All right, and then the last one. How would I write 5 to the 1/3? Not 5 cubed, but the cube root of 5. What about, that's supposed to be 5, excuse me. That's just supposed to be a 5, y'all. Not a 25. Don't know where I came up with 25. Well, I do know where I did, but change that and we'll start over. Sorry. I'm going to be making it too hard for your first problem if I do that. All right, so we have 5 to the 1/3 times 5 to the 2/3. 5 to the 1/3 is the cube root of 5. The next one, since we have a fraction exponent, we know we have a radical. The index is 2 or 3? 3. 3. What do we do with that 2? Okay, we can either put it inside or outside. Here, it makes more sense to put it inside. Yeah, this is a 3, this is a 2. All right, and so we end up with the cube root of 5 times 5 squared, which is the cube root of 125. 5 squared is 25, or you could look at it as 5 to the third. And so what's the cube root of 125? 5. All right, so that is your first set of kind of problems. I have a YouTube channel. Okay, so in radical form, anytime you see a fraction exponent, that means you're going to have a radical. The x goes under the radical. Which of these two numbers is the index?
3.
Okay, now where do we put 5? There are two options. You can put it here or here. Sometimes this is more useful. Sometimes this is more useful.
So what's our answer?
Either one.
Wait, that's the answer?
Yes, that's the answer.
You can't break it down, right? So if we write either one.
Either one, you get credit.
Don't tell me the next one.
Okay,
Let me put it on the board.
now we'll wait because we have a little trick on this one. Okay, so there's a trick. That is a negative exponent. You learned exponent rules in middle school and you probably hadn't looked at them since, other than multiplying and dividing. When you multiply, you add them. When you divide, you subtract them. But what if there is a negative exponent? What does that do to your term? Flips it. You're right. Okay, it does. It's very good. That's going to make it 1 over d to the 3 halves. Okay, so you're going to make it 1 over. You flip it. You do the reciprocal. Now, you don't change the 3 halves. You don't make it 2 over 3, but you change the whole thing. You bring it to the bottom when it has a negative. So because of the negative, I'm going to write myself a little note right here. Because of the negative. All right, because of the negative, I make it 1 over that. And now, what goes under the radical?
Put it on top. I mean 3.
A 1. And then, you're right, the 2 goes here. What do I do with the 3? I put it behind the D, either in there. Now, y'all, this was a bad example. Let me tell you how. I know. But what we are going to end up with here, and I'm not going to make you do it on this one, but I just want you to know for future purposes, the square root of d to the third, this is going back to Mondays. No. How many groups of 2? If I wrote this out as d times d times d, and I'm trying to simplify the square root, wouldn't I have 1d come out and 1d stay under? Going back to Monday. And then I would have to simplify this, and so really you'd have square root of d over d squared, but I'm not making y'all do that. I just wanted y'all to know that this isn't the most simplified version, but I didn't ask you to simplify. I just asked you to write it in radical form. All right, moving on. This is example 3. We're going to write it in exponential form. Okay, example 3, you're going to write in exponential form. I'm going to pause the video while I write. Pay attention. Okay, this first one can be a little tough because we know that this is ab to the third. I don't want to do it that way. I was going to say raise to the 1/2. For those of you that did, you don't have to erase.
Already did. Oh my God.
We can just raise it to the 1/2 power. Where am I getting 1/2?
I don't know. Tell me. So you want to write it down?
You can if you already started.
The A. The A.
The square root, okay? So that would be, look, that's going to be A to the 1/2, B to the 3/2, because you have 3 times 1/2. Why did I write 1 over B? A to the 1/2, B to the 3/2. That's your answer. But guys, there's a different way of doing it. Okay, there's a different way of doing it that you might like better. Yes. Yes. Okay, so I'm going to do it in red. There's an understood 1 with this A, isn't there? Okay, and what's the understood index? 2. All right, so we treat each variable separately. Okay. Which number goes on top for the A, the 1 or the 2? The 1. The power goes on top, and the index goes on the bottom. What is out there? Okay. Fried chicken on Toledo. All right. With B, the power goes on top, the index goes on bottom. Okay? Either way is fine. You get the same answer. A lot of people think that that second way is easier because you just take whatever the power is, put it over this, take whatever the power is, put it over his. Yes.
Is it always going to be understood 2?
If there's nothing there, it's understood 2. It's kind of like with exponents. If there's nothing there, there's an understood 1. Well, with radicals, if there's nothing there, there's an understood 2, a square root. All right, and then we look at this one. So I'm going to have W. What's going on top, 2 or 3? 2, and then 3 goes on bottom. What's negative? Is the W negative, or is it the 2/3 that's negative? The 2/3. A negative exponent makes us put a 1 over it. So because we have a fraction, we have to use a negative exponent. So fraction, or specifically anything in the denominator, equals negative exponent. So if you have a denominator, that means you have a negative exponent for that variable. See how W is in the denominator? So it has a negative exponent. All right, take out your whiteboards. Take out your whiteboards. Get ready. Okay, so we look at this problem, and you look at it, you're like, well, Miss Sutter, we can't multiply those together because one of them is a 6th root, and one of them is a cube root. We're in our notes now. Notes. One of them's a 6th root, and one of them's a cube root. We can't put those together. Gracie.
Do you separate the 6?
What do you mean separate?
Like you take cube root of 5 times cube root of 5 times.
You can't do that, but you have the right idea. We're going to try to get them in a similar form. Okay? With our new knowledge, we can rewrite this as 10 to the what? 1 over 6. Okay, because it's the 6th root. We can rewrite it as 10 to the 1 over 6. Because the index has to go in the bottom. So what would this one be? 10 to the 3rd. Think about it. The 3rd root is 10 to the 3rd. The 6th root is 10 to the 6th. Okay? So we rewrite them using our rational exponents. Now, what do? We've already looked at this today. When you have the same base, but different exponents and you're multiplying, what are you supposed to do with the exponents? Add them. So 1/6 plus 1/3. Now, here you can use your calculator if you have to. But how many 6s is 1/3? 2 sixes. So 1 6 plus 2 6 is 3 6, which is 1/2. Again, if you had to use your calculator for that, go for it. 1 6. Huh? So, no, that doesn't work every time, but that's a good thought. 1 6 plus 1/3 is 1/2. And so how do we write that in simplest radical form? How do we write something to the 1/2? The square root. Good. All right, y'all ready to try one?
No.
Well, you're going to get two anyway. So I know that you can just type this one into your calculator and get the correct answer, but you're going to have to show me your steps so I know that you understand the reasoning behind it. So we're going to rewrite this as a radical. What's going to be the index? Now we have to make a choice about where to put the 4. Do we want to start by taking the 5th root of 32? Or do we want to start by raising 32 to the 4th power? 32 to the 4th power is 1,048,576. I don't want to do that. So I am going to put my power on the outside. Now, the 5th root of 32. Some of you might know off the top of your head that it's got to be 2. But if you didn't, this is 2 times 16, which is 4 times 4. Oh, look. There are 5 2's. Why did I circle 5 2's? Good, because it's the 5th root, and so I have 5 2's. So that's going to be 5 raised to the 4th, which is 625. Why did I say 5? Thank you. Yeah, I told y'all the answer was 16, and then I did this. Okay, 2. The 2 comes out because there are 5 of them. So it's 2 that gets raised to the 4th power, which is 16. Please excuse me. I have had such good attention span today, and then I just lost it. All right. No. Okay. The next one that we're going to do is a little bit more difficult, but I have full faith that you can get it and understand it. See, that one only took up half the screen instead of a whole screen like I said it would. 9y times the square root of x raised to the 3/2.
Oh, all of that.
All of it. Raised.
Okay, well, can you show us how to do it without us even trying it? Because I'm going to try.
We're going to do it together. This is still a do together problem. We kind of have like an I do, and then we do, and then you do by yourself.
Is that 3/4 or 3/2?
3/2. All right, first what I want to say is we're going to rewrite this as 9 to the 3/2, y to the 3/2. Now this is a little confusing here. Okay, let's just go ahead and put square root of x to the 3/2. Everything gets raised to the 3/2 power. Everything's going to get raised to the 3/2 power. Oh, well, that's kind of smart, too. Okay, I'm going to work it out 2 ways for you. I like your way better, Sierra. All right? So I'm going to go this way, and then I'm going to show you Sierra's way, which is an even better way. All right, so I do this, and I have...
Do we not write down this way?
No, write down this way and the other. Because sometimes it's one of those where you're going to have to look at the problem and say, is it going to be easier to work it this way? Or is it going to be easier to work it this way? So I look at this. This means the square root of 9 to the 3rd. And this means the square root of y to the 3rd. But what is this mess right here? Okay. It's not x to the third. So this was actually, if we go over here to the side and just think about just this part right here, that's x to the 1/2, and we're raising it to the 3/2. So it's really x to the 3/4. Yeah, that's confusing as all snot. Like, it's just bad. Okay. Look. The square root means x to the 1/2. And then you're raising it to the 3/2 power. So you say 1 times 3 is 3, 2 times 2 is 4. So when we write this over here, that's going to give us the 4th root of x to the 3rd. It's my favorite place to walk. Sorry. I do. I just kind of go like right here. And then I turn around. And then I stand right in front of the board. Okay. So, what is 9 to the 3rd power? Well, it's not 27. It's what? And what's the square root of 729? It's 27. All right. Now we have to think about this. We got to think about this. And I went too far because I didn't think about it. My original problem was given with a radical and an exponent. Is it going to look right to put a square root and then a 4th root right next to each other? No. So I'm going to go back and rewrite this as y to the 2/3, x to the 3/4, and call it a day. Okay? Yeah, now we got to do the other way. Yes. Okay. So, doing it the other way. Okay? Doing it the other way. So, Sierra said, why can't we just start off by changing it? So, if I do that, I'm going to try it. We'll see how it goes. Let's make it blue. Let's see what happens. So we would take the square root, since the index is 2, okay, the square root of 9y x to the 1/2, and then raise that to the 3rd power. Okay, so because it was 3/2, the 2 tells us we're going to take the square root. 2 is the index. And since it's outside the parentheses, we're going to take the square root of all of that. But x under the square root means x to the 1/2. And then we're raising everything to the 3rd. Okay. Now, what's the square root of 9? What the square root of 9 is 3. But guys, I can't take the square root of this stuff. I can't take the square root of this stuff. So I just have square root of y x to the 1/2 raised to the 3rd power. Like, I can't take the square root of anything but the 9. Third. We're just bringing that 3 down from there.
Okay, so how do we get a completely different answer?
Okay, here we go. Here we go. What is 3 to the third? 3 raised to the third power is 27. Now, the square root of y means y to the 1/2. But we're raising it to the third power, so it's 3/2. Okay, this was y to the 1/2, but we're raising it. You know what? I'm going to throw in an extra step. Hold on. Just hold on. I'm going to change this. Make the whole extra step. Rewrite this as y to the 1/2 and x to the what? Okay. I'm taking the square root of x to the 1/2. That makes it the 4th root, guys, overall.
Okay, I have no clue.
So maybe this way wasn't faster. And then you would raise everything to the third power. So 27, y to the 3/2, x to the 3/4. You get the same answer either way, but